Hey everyone, my name is Karina, and I'll be talking about the moral justification of a specific fairness metric, and that is statistical parity. And this is joint work with Christoph Heitz and Michaela Loy. So our paper sort of consists of two parts, and I'll talk about the first part at a regular presentation level of detail, and then we'll jump up to a higher level to talk about the second part of the paper, and I'll just give you the outline of the argument that we make there. So what's our motivation for talking about the moral justification of fairness metrics in general, and then in the case of this paper about the moral justification of statistical parity? So when we want to audit a system for fairness, there are a bunch of different metrics that we can choose from. There are mathematical definitions of what it means to be fair. But we also know that mathematically speaking, it's pretty much impossible to fulfill all of them at once. And so in practice, we have to choose which fairness metrics we care about. And this choosing has to be motivated by philosophy, by a moral perspective. And so there is some guidance on this out there, but it's still lacking. And so what we wanted to do in this paper is do a deep dive into the morality of one of these metrics, and that is statistical parity. So the question that we're asking in this paper is, when should we care about statistical parity and when should we try to enforce it? And the first question that we have to answer for this is, of course, what even is statistical parity? You may know it under the name demographic parity or independence, as it's called more generally in the FAirML book. But if you don't know the concept, it's pretty easy to explain. As with all other group fairness metrics, what we do for statistical parity is to compare different sociodemographic groups. So this could be groups based on gender, race, religion, etc. And here we take an extremely simplified example where we compare the orange group to the blue group. And we'll take the example of hiring. So a company is trying to hire a bunch of new salespeople. And they get 6 applications from people in the orange group, and they hire 2 of them. That means that the hiring rate for the orange group is 1/3. If they now get 9 applications from people in the blue group, this means that they should also approximately hire 1/3 of them, so 3 of them. If they hired 6 people from the blue group, that would make the hiring rate of the blue group 2/3, which would violate statistical parity, because statistical parity demands that in this case, the hiring rates are the same for all sociodemographic groups. And more generally, statistical parity demands that the probability of getting a given decision is the same for all groups on average. And so in this first part, we asked the question of when to enforce statistical parity by looking at existing literature on this. And we'll specifically look at one paper and build on that. And so we look at the framework that's proposed in this paper and then ask ourselves whether this framework that's provided there is sufficient to talk about the moral aspects of enforcing statistical parity. And we find that there is a piece that's missing, and so we extend the framework. And this is the paper that we built on. It's the Impossibility of Fairness paper by Sorel Friedler and her colleagues. And what the paper does is it provides a framework for how to think about the inequalities that we measure in the different hiring rates. And so the hiring decisions that are made by the company are represented in what the paper refers to as the decision space. Ideally, the company could make these hiring decisions based on the candidate's actual skills and abilities. So ideally, they would just know how good the candidates are at making sales, how well they work in teams, how flexible they are, how well they know a certain tool, etc. But they don't just know that. Instead, they just have to measure it in some way. And this is what is called the observed space. So the actual skills of the candidates are the construct space, but then companies just have measurements of that. That's the observed space. So for the case of hiring, that would be the CVs of the candidates, the impressions that the HR department gets from the interviews or from talking to the references that the candidates provide. And now this observed space is, of course, not a perfect representation of the construct space, but it can be biased. And if there is bias that is introduced from the construct space to the observed space, we speak of measurement bias. An example of this would be two students who are in their final year of university and soon have to take a standardized test. And we assume that after university, they'll both apply for the same job and put their standardized test scores on their CV, and the company will take this into account when making the hiring decision. And so now we assume that student A has wealthy parents who can afford tutoring for that standardized test. Student B doesn't have wealthy parents and can't afford tutoring for the test. So now if we assume that tutoring improves the students' test-taking skills, but not their actual skills that would be relevant for the job, that means that student A will appear to be more skilled because they have a higher test score, even though they're just as skilled as student B. So they're both equal in the construct space, they have equal skills, but because of measurement bias, it appears as if student A is more skilled than B because they have a higher test score. And so student A's chances of being hired are actually higher than the chances of student B, even though, again, they have equal skills. So this is a case where it automatically or intuitively feels as if measurement bias is unfair. And so Freela's paper uses this to point to a scenario in which it seems as if we should enforce statistical parity. And so on a group level, this scenario would be that the blue group is just as skilled as the orange group in the construct space. But then because of measurement bias, it appears as if the blue group was more skilled than the orange group in the observed space. And now this will probably lead to the company hiring people from the blue group at a higher rate than people from the orange group, even though on average, both groups are equal in the construct space. And so in this case, we could enforce statistical parity to correct for this measurement bias, and that is what the paper suggests. What this paper sort of leaves unanswered is the question of what about inequalities in the construct space? So what if the blue group is actually more skilled than the orange group on average? Is there then still a reason to maybe enforce statistical parity? And for this, we want to understand why there are differences in the construct space. And so to clarify our thinking about that, we extend this framework by adding another space. And the space comes before the construct space, and we call it the potential space. And in the example of hiring, it's just the individual's predisposition to be flexible, to work well in teams, and to essentially develop the skills that are needed for the job. So every candidate starts out with their innate potential at birth, essentially in the potential space. John Rawls refers to this as native endowments. And this potential is then developed into actual realized abilities, which are represented by the construct space. The company then observes these realized abilities, and these observations fall under the observed space, and then the company makes decisions based on that. Now, if we have inequalities in the construct space, the question still remains, where are these inequalities coming from? And similar as with the concept of measurement bias, which occurs between the construct space and the observed space, we could have a bias between the potential space and the construct space that influences how potential is developed into actual abilities. And we call this life's bias. And so for an example of that, take again the two university students. And we assume that they're equal in their innate potential. And so they're now in their last year of university. And let's also assume that up until that point, they have the same skills. But now student A, who has the wealthy parents, Their parents are also very well connected, and they get them an unpaid internship. And student A can take this internship because they don't have to worry about paying for tuition fees. Their parents are taking care of it. Student B, on the other hand, has to worry about paying for tuition fees. They don't get the opportunity to do an unpaid internship, but even if they were given this opportunity, they couldn't take it because they have to pay their tuition fees, and so instead they work at the local bar. Now, during this last year of university, they actually developed different skills. And if now the company that they both apply for values the skills that the unpaid intern developed more than the skills that student B developed, student A's hiring chances are higher, simply because they have a different socioeconomic background. And now the question is, should we correct for this? Should we correct for life's bias? And to answer this question, we take a step back to look at measurement bias and think about what made measurement bias intuitively unfair to us. And so we could point to different reasons for why we think measurement bias is unfair, but we'll focus on the question of responsibility. So we would say that individuals are not responsible for how their skills are measured or perceived, and this is what makes measurement bias unfair. And so we should correct for it. And now we can apply the same concept of responsibility to life's bias. And we could ask, are individuals responsible for life's bias? And if not, then correct for it. And so we sort of have to split between unjust life's bias and just life's bias. And unjust life's bias is what we should correct for, and just life's bias is what we should not correct for. And so an example of unjust life's bias is this example of the unpaid internships that we just went over, where students have no control over their socioeconomic background, so it's not their responsibility. They're not responsible for not having access to the same opportunities. So this would be unjust life's bias. And then an example of just life's bias would be individual choices. So as an example, take two students who are equal in their innate potential, but they just choose different paths in life. And they do so willingly and conscious of the consequences without being coerced into doing so by family, friends, or society. And so they do develop different skills, and they will be different in the construct space, even though they have the same innate potential. But this is due to their own individual choices. So they're responsible for it, and we would consider it to be just life's bias that we do not correct for. And just as a quick side note, if we just look at responsibility to differentiate between just and unjust life's bias, or the bias that we have to correct for and don't have to correct for, this would arguably be too broad, and we might correct for too many biases. So there are actually examples of life's bias that individuals are not responsible for, but that we would still consider to be just life's bias. But because of the time constraints, we can't go into the details of this. So if you're interested in this, we do encourage you, of course, to go take a look at the paper. And so just to recap and summarize the entire framework, individuals are born with an innate potential that is then developed into realized abilities. This can be influenced by life's bias. And then realized abilities are observed or measured by the company at the time that they want to hire. This measurement can be influenced by measurement bias, and the company then takes the observations to make hiring decisions. And now let's jump up to a higher level and talk about the second part of the paper. So when we look at the first part of the paper, we get the impression that we should probably correct for inequalities that are introduced by measurement bias and unjust life's bias. And so in the second part of the paper, we put this impression into a formal rule and then check if this holds as a general rule. So whether we can use this impression to, in all cases, decide whether we should care about statistical parity or not. So the idea would be, if I have an application and I want to figure out what fairness metric I should care about, whether I should care about statistical parity, I would take this general rule, apply it to my case, and then know whether I should enforce statistical parity or not. And we check whether this holds as a general rule by looking for counterexamples. So this is the formal definition of the rule, and it's if and only if the sociodemographic groups are equal in the potential space and there is measurement bias or unjust lives bias, then statistical parity should be enforced. And so to visualize this for our example, this would mean that the blue and the orange group are equal in their innate potential, so in the potential space. But then there is unjust lives bias or measurement bias, which leads to differences in the observed space. In this case, the blue group is perceived to be more skilled than the orange group. And so what this would mean in practice is that the company would probably hire people from the blue group at a higher rate than people from the orange group. And so in this case, our rule says we should enforce statistical parity to ensure that the hiring rates are equal. And so now the question is this a general rule? Can we apply this to all cases to figure out whether statistical parity matters in our context? And we do this by looking for counterexamples. And sure enough, we do find counterexamples, unfortunately. And we find two of them. And so we have a counterexample for both directions of the rule. So the first counterexample is a case where the preconditions to enforce statistical parity are met, but intuitively it seems like statistical parity should not be enforced. And then in the second counterexample, we look at the opposite direction, and we have a case where statistical parity should intuitively not be enforced, even though the conditions to enforce it are met. And both of these counterexamples are sort of based around the fact that with the framework that we proposed, we can only look at past and current injustices in the form of lives bias and measurement bias, but we can't consider the consequences of the decisions that we take. So when we enforce statistical parity, this of course changes the decision space, the decisions that we make about individuals, and this has consequences for these individuals, but they're not at all considered in this rule. And so our takeaway of the second part is that it's not enough to just look at the unjust causes of inequalities in the decision space, but we also have to consider the consequences of the decision space and the aftermath of that. And so to summarize this, let's go back to the original question that we asked, which was, when should statistical parity be enforced? And so what we saw in the literature was that measurement bias seems to provide us with a good reason to enforce statistical parity. We then looked at lives bias and saw that we can split lives bias into unjust and just lives bias, and it seems like we should correct for unjust lives bias. But then in the second part, we also saw that both of these things together are still not enough to decide whether we should enforce statistical parity or not, because they don't consider the consequences of the decisions that we take in the decision space. And so these consequences also have to be part of the equation. And so this is sort of a negative conclusion to our paper. We couldn't find a general rule for when and when not to enforce statistical parity, but it did provide some constraints on future work, and we did identify some elements for what matters when we want to figure out which fairness metric we care about. And that is past and current injustices in the form of unjust lives bias and measurement bias, and then also the consequences of the decisions that are taken. Yeah, so thank you for taking the time to listen to this talk, and I'm looking forward to an interesting discussion with you. Thank you so much.